Good morning to all of you, and welcome to the 17th webinar of the SLIIT Industry Placement Internal Program. And today there will be two speakers who are also the past graduates of SLIIT. So first, I'll introduce Mr. Jude Niroshan. He's a software engineer on commerce tools in Germany, and he's also a certified professional Google AWS Cloud Architect, and also open source developer and mentor at OpenMRS. So, Mr. Jude, over to you.
Thank you, Mr. Rajit. So let me quickly start sharing. Can everybody see my screen?
Yes, I can see the screen.
Okay. Okay. So as Mr. Rajit has already mentioned about me, so I'm Jude, and I was a student, and I was graduated in last year or last 1.5 years ago from SLIIT. So today's session is all about what are cloud platforms, and a general introduction, and most essential knowledge that you must have when you are working with these cloud platforms. So most of the things that we discuss here today are common for any cloud platform. So I believe that you might have some experience on any of these cloud platforms, and you might know about the fundamentals. What is cloud? What is a cloud platform, and why we are using these services, and the basic idea. So if anybody doesn't clear about those, so let me give you a brief introduction. So cloud platforms, as you might have known now, no company anymore and in near future is going to maintain their physical server machines. So what I mean by that, if you have a desktop in your house, it is a computer, right? So this is mostly you are using internet and going to websites and different internet services. So there is some other place on the internet that is requesting that is serving these kind of requests and serving your requirements. So these we are called normally servers, and these servers has to be operated and turned on, switched on, and working somewhere in the world. So in this case, now we are using now we have outsourced this hardware infrastructure to some other company to maintain for us, and we are paying the bill for them. So in this case, now today we have Amazon Web Services, and Google has provided Google Cloud, and Microsoft has provided Azure, and IBM has provided IBM Cloud, and Oracle Cloud, Alibaba Cloud. There are a lot of vendors like this. So what is their business? So their business is they are selling server machines to anybody who wants, and they have anybody who is using them, they have to pay some price. So this is the core concept, and all these services are based or accessed by internet. So that is the main idea here. So let's move ahead. So if you take any cloud provider, we have basically 3 pillars. We call 3 pillars, the first 3 one. But when you are working with this, you might also want to have the login and monitoring part. So basically, if you want to build a computer system, you need to have a network feature, and you need to have the compute capacity, and you need to have the storage capacity, and you need to have the login and monitoring. So these 4 things are essential to build any computer infrastructure. So so I will go ahead with all of these points and describe you how and why we are using these sort of services, and what are the options we have. So let's move ahead. So before we start any of those fundamental things. You need to understand how these services or how this business works. So I have put a map here. This is for Amazon Web Services. So this is how they have deployed their services, or this is how they have their physical server machines or server farms and data centers located around the world. So you can see there are a lot of places in the world that they have their physical server farms. And so normally we have these two terms we call as regions and zones. So a region is a large geographical area. So if you take EU has a one geographical area, and you have Asia Pacific, and you have one region for uh, South America, and America has a lot of regions because America is a very huge country. So so region is the topmost layer that you need to understand. If it is if it is a region, that means it's a very independent geolocation data center or server farm. And within this region, they have uh, subset of groups that they called as zone. And a zone is more like um, a center or a building that located inside that region. So if you take US East area, and there could be multiple buildings that they maintain. It is not one block next to the other, but it could be some other different places. But if you look at the higher overview, it is in the same area, or if it could be in the same state, or it could be in the same province. So that is the idea. So normally, if you have deployed, or if you have hosted all your servers in a one zone, and if you are deploying another new service in a different zone which falls into that same region, usually these connection between these two regions, which falls within one particular region, will be faster and more cost effective, because it is not really far away. It is inside the same province, or it would be the same region, right? And when you look at um, the cloud providers, they use a convention like how you label something inside the cloud. So basically, we start with the region and hyphen the zone. So if you take this example that I have put here, which is US Central 1 dash A. So US Central 1 is a region, and dash A is the zone. So you could also see US Central 1B, US Central 1C, like this. So which means the US Central 1 region has three ABC, three zones inside it. So I hope you all already know about this stuff. I was just refreshing your knowledge in case if you have forgotten. So let's move ahead. And I think this is clear about what are regions and so on. It's a very simple concept, but it is very important, because down the line you might get confused where these services and the zones are coming from, and why they cannot communicate sometimes. Yeah. So let's move ahead. And so let's talk about networking. So networking is very, very important. And without a network, you are totally isolated. You cannot do anything much. So the networking is a very essential part. And when it comes to the cloud or other platform, it is there for you. So normally you used to create physical networks in your in a company or in a building. That's how I as far as I could remember, that is how I learned when I was in second year. So there was these routers and switches that you had to configure them. You had to write routing tables, and switch. You had to create these mappings and all. So you have the same idea when it comes to cloud platforms also. So because now we are not going to have our physical servers inside our buildings. Instead, we are using these cloud platforms. So, so you might remember that in networking we have these subnets, and we have different networks for different departments, and we have nodes, and we have protocols, how we are going to communicate with them. So everything is here, and but when it comes to cloud platforms, we use a different term. So this term is, we are calling virtual private VPCs, virtual private communication. Or yes, so virtual private computing actually. So this term, it's just the same name. It's just another term. But what you have to know is it's the network that we are going to create inside our infrastructure. So you know what is a network, and what are the protocols, and how a computer network is working. But this time it's everything is depends on a software based configuration. So you don't see a hardware level devices usually, but we also can have, but it is a very rare situation that you have to deal with physical devices. So as I told you, VPC it's the term in cloud computing that we are using for networking. So you can see these 4 points that I have put here in the slide. So the first one is it's a software defined network, and everything is you can control through browser what is happening there and how to configure. And when it comes to cloud platforms, why we need most of the time to go for cloud platforms is to have the global footprint. So what does it mean by global footprint? That if when you deploy or when you serve something in the internet, you allow anybody in the world, around the world, any place, that who has internet access can access your service. So this is what it means by global presence or global footprint. So this is very important for any business today, because they want to reach as much as customers around the world so that they can have more revenue in their business. So that is why the cloud platforms are popular these days, because every business is trying to reach many customers. So it is very easy to create global networks through these software-defined networks, because you don't have to go to different countries and set up server machines there. Everything will be done for you by these cloud platforms. So it is very easy. And the regions and zones, as I explained you at the beginning. So the region is a very large geographical area. So inside the region, you could have multiple zones. And when it comes to networking, we usually create a subnet for a one region. So for example, if you want to serve all the South Asian countries in a different way, but all the US or US related customers in a different way. So how does these sort of logics works? How does this differentiation happens? In the beginning, I mean, like in few years ago, we used to write these sort of logics manually in the source code and have a lot of different mechanisms. But now with the cloud, we can deploy different services into different regions and say, okay, for this region, you have a different version of our source code. It will act upon like this. So it is very easy in terms of that kind of requirements satisfying. So a subnet is the same concept that we have in networking. And the next one is the ingress and egress terms. So ingress is anything that comes inside your network. So anything that comes inside your network, it is called as ingress. And egress is something going out from your network. So yeah, this is very straightforward. I think everybody can understand what are these two. So that is nothing much more about these two terms. These are two terms that they use in cloud infrastructures. So as I told you, like uh, when it comes to a cloud platform, this is the normal hierarchy. We start with project and network, subnetwork, region, zones, IP addresses, VMs, routes, firewalls. So all of these terms or all of these aspects are essential to build your own network inside the cloud provider. So a cloud provider, it's nothing, but it's some big company is providing you computer machines for you to run your infrastructure, for you to run your source code, or for you to run your business there. So you need, if you have developed their your infrastructure in your company inside your building, you might also need to think about these sort of things, except the regions and so on. Everything else will be usual. I mean, like you have to use them. So you can see there are two images here. So the first one is all about when we create networks, we might have situations that we need to create, we need to communicate to different networks, different private networks. So so there could be two different ways. It could be either directly communicating inside from one network to the other, or it could be that we go outside of network and go to internet and comes back uh, to the other network from the internet. So it is a very common use case that you have to use both situations, but the recommended way is to go from one network to the other inside without going to the network. So this facility is actually provided by default from the Google Cloud Platform. So this is very unique that they say that if you have a subnetwork and if you want to communicate to another subnetwork, or subnetwork is a smaller set of machines, or it's a smaller scale network. So you have network A and you have network B, and you need to communicate from network A to network B. But you don't want to go to internet and comes back from the internet. You have to avoid using internet, but you can simply communicate from this network to the other network without even touching the internet. So this feature is already provided by Google, but also it is there for Amazon Web Services, but you might have to do some configuration. But when it comes to the Google Cloud Platform, it is by default, it is there like that. And how do we create networks? Usually it depends on the requirement. It is not a good practice that you put everything inside one network. And if you know that your business or your infrastructure will scale up, so you might need to pay some attention and take some time to design your networks accordingly, that you might not come to some constraints. There are some constraints that you cannot scale your network infinitely. So there are limitations like that in physical limitations. So that is why it is better to create separate networks if you are working with a very complex project. Mm. So let's move on. So when it comes to networking in GCP, uh, we have this basic idea about firewall rules, routes, load balancing, and DNS. So I believe everybody is here familiar with these basic concepts in computer science and networking. So the firewall rule is something that controls what is coming inside and what is going outside of your machine or your network. And the routes, you simply say this is a link between the two different subnets. Usually in Google Cloud, you can say either, okay, I will hard code. If you have any traffic coming from this network to that network, use the two IP addresses and connect them. Or else you can say dynamically, I don't know the IP addresses because the IP addresses are maintained by Google Cloud or Amazon Web Services. What I will do is, if you want to communicate with this network to that network, use these two names and try to find the network path. So so that it is kind of like a dynamic way, because you don't know the IP addresses, but it will work because you are mentioning go from this place to that place. Normally we are using labels for those identifications. Yeah, so the route is something like a road, how to go to from place A to place B. And the load balancing part, load balancing is like how you are going to distribute your uh, user request. So if you take your mobile and if you open the app Facebook, so it is a request that you are asking the Facebook company, okay, I need to use your service now, so provide me all the resources what I need. So it is a request that you make from your mobile app to the Google to Facebook service. So from the Facebook perspective, it is not only you, but there are millions or billions people are asking uh, different things. So you need, from the perspective of Facebook, the Facebook has to have the capacity or the availability that to respond to everybody who is asking these resources. So inside the Facebook infrastructure, there is no one machine that can ever handle this amount of load. So they need to distribute their workload for different machines. So that is why we have this set of load balancing. And load balancing, here you can see 5 different types of load balancing. And as you can see, 3 of them are global and 2 of them are regional. So what is HTTPS load balancer? It's basically for their just to maintain your HTTPS request. So you know what is HTTP request. And SSL proxy is typically used for IoT devices. Or if you think about IoT deployment, and all these client certifications and everything will be managed by this particular SSL proxy. And TCP proxy is usually for layer 4 level. So it is not for HTTPS, because TCP it's a little bit a fourth layer in the this ISO uh, hierarchy of the networking layer. And so the TCP layer cannot see the HTTP level packet identification, stuff like that. So basically, if you have some sort of a system that works with TCP layer, and you need to divide your incoming load, you use this particular load balancer that they are providing. And regional stuff, usually within your network, within your inside your infrastructure, if it is very complex and you need to go for different paths and different sections when you are doing some stuff inside your business, you need to have different subnetworks. So how do you divide the internal load? It is depending on your scenario. So you can see that there are TCP internal and network load balancer. So these are usually for regional level, which means within subnet levels. And the last point is DNS service. So you know a DNS is some service that we call as DNS, which can handle the IP addresses to domain name, a particular name, that they can convert this a number to a character string. So this is also there in Google Cloud as a service. I think in AWS also we have this Route 53 service and DNS along with that. You can use those. So I think you can understand why we have this networking, and these are the fundamental things. So uh, it is not possible for me to cover everything related to networking, because it is very huge. But right now, I believe that you have some basic idea. If you are given a cloud platform and you have given a project by your manager or by your line manager and asking you to deploy this infrastructure, and even you don't know anything, right? But you start to going through documentation. But after this presentation, you know these keywords, like you are not completely lost. You have some idea where to start off and what are these networking, what are these load balancing, stuff like that, why we need them, like that. So the next big thing is about cloud platforms are about this compute option. So the compute option is very essential in any cloud platform. You can see in Google Cloud, currently we have actually five, but I have only listed four: the compute engine, Kubernetes engine, app engine, and cloud function. The one missing here is the cloud run. So cloud run is basically if you have a container that you need to spin up and run it, you can just simply use that service. So these are services that provided by Google Cloud. So in Amazon world also, we have the similar services like these. And you can see there's an arrow that goes both sides, which says, if you go to leftmost service, which is Compute Engine, this service is very highly customizable, and therefore you need to have some very in-depth knowledge about how the computer networking servers are working and how to manage them. So this is where usually your network knowledge comes into play. So usually developers have limited knowledge when it comes to how to manage servers, how to maintain your server infrastructure. So if your business is working with compute engine, they need to have some special people who has this knowledge. And if you move on to this rightmost service, which is cloud functions, as you can see, you don't need those such people to work with cloud functions. The developers alone can work with those, because in cloud functions, we don't care about servers, how they are working. We simply create our source code, we write our source code and say, okay, I have the source code, please run it. I don't know how I don't have any network knowledge at all. So yeah, so these services usually provided by any cloud provider, because there are different people asking different kind of requirements. So these four types of services will satisfy like almost everybody who is using cloud services. So compute engine, it's a computer that currently you are looking at this presentation. It's a one computer, right? Or sort of a computer. So when it comes to Google Cloud or Amazon Web Services or any other cloud provider, we have these same machines, but it is not in your house or in your classroom, but it is inside in a different country somewhere. You never even saw where it is, but it is there for you that you can access from the internet. So compute engine, it's basically a virtual machine. So, but virtual means like you cannot see the physical stuff, but you can get everything what you need in from a computer. So it has a memory, it has a hard disk, it has a compute power, it has everything that as you have in your normal desktop machine. Um, so you can even modify this machine, or you can even assemble this machine as you want. Like if you want more hard disk, and if you want more RAM, if you want more GPU, uh, this set of things you can change whenever you need. But as I said, cloud computing is it's a service, it's a business that the big companies are providing for. So you need to pay some money for those services, right? And in cloud computing, we have some a fancy term called preemptible instances, or like spot instances. So these in cloud computing, or any other provider, any other cloud provider, we use the term instance. So instance is a computer. It's a computer, right? So whenever you see, if you are talking about instances, that means a computer. But yeah, so you can see preemptible or spot instances. They are short-lived, and they are usually for something you need the compute power very much, but not for long, like only for a 1 day. That's enough. I'm happy with that. So in this situation, you can use these kind of some sort of like a fancy term that they provide, like spot instances. So it will it will be spontaneous, and it will not there when you woke up next day. It's gone. So it is not guaranteed that these service instances are there every time, but it's for a short-lived period. And Kubernetes engine, you know about Kubernetes, everybody's talking, and you might have even worked with them. So in Google Cloud, we have Kubernetes engine, and Amazon, we have the same name, but they use EKS, Elastic Kubernetes Service, and in Microsoft, we have Kubernetes Service, AKS, Azure Kubernetes Service. So at the end, with all of these fancy names, different services, they are talking about open source Kubernetes in the solution that provided by Google. So it is an open source, and you know what is Kubernetes, but you don't have to worry about how to configure a Kubernetes cluster. So everything is provided as a service. So as I mentioned here, it is ideal for microservices. As you might know now, Kubernetes is ideal for microservices, and these these three services that I have shown as pictures, you don't have to know about how to configure Kubernetes cluster, what are master nodes and what are scheduling, how the pods are working, like that. Everything will be there done for you. That is why you are paying some money. So it is you don't have to know anything about them, and that's why it is very easy to get started with, and auto scale and everything will be there for you, and monitoring is also there for you. And the most important thing is you are not going to be out of date. So if you are if so usually these cloud providers, they have hundreds or thousands of software engineers and network engineers that they have hired, that they are working full time, that to provide you the best experience. So they are always providing you new upgrades are there. You can simply make it available just clicking on few button clicks away. Um, so the next service is App Engine. It's a very straightforward service that you can deploy web applications. If you have a web application like a Node.js or React.js application that you need to go live, you can simply use these sort of services and host them. And so anybody outside internet, like outside of coming from internet, can access them. So usually these are very straightforward and very easy to use. If you don't want to um, think about how you are going to make your internet communication work and how the networking going to happen, you don't have to worry anything at all. So moving forward, next most easier option is the cloud function. So cloud function, it's a script. It's a script that you can run whenever you need. So it is very reliable and very cost-effective way. So normally, you know that there's a term called serverless architecture. So serverless means you don't know how the computer or the server machines are going to be there for you. But what you know, there's a service that I can use at any time at any scale. So these cloud functions will help you to achieve that goal. So cloud functions are just a script that you can run at any time, at any scale. It could be from 1 to 10 to millions to billions or trillions. So this is a guarantee that they say from any cloud provider, that they are highly reliable, and you can expect any load that they can manage. So let's move on to storage options. The storage, we usually have two types of storage, right? So normally you have the hard disk level, the storage that you attach to a machine or to an instance here. So, or else your data size is very large, or data is very different, that you don't want to save in a hard disk, but you want to save in a different place that you can access. So these two differentiations are there. So the persistent disk, what you can see on the left side, it's a hardware physical component that you can attach to a computer, right? And there are something called local SSD drives and normal persistent disks. So you know now we have normal hardware drives and solid state drives, SSDs. So you know that SSD is fast and it is very modern in terms of hardware manufacturing capability and how they are working, how fast they are. So these different types of hardware devices are there in the cloud platforms. When you are creating a computer or when you are creating an instance, you can choose either you want normal hard disk or you need the SSD hard disk. So this option is there when you are creating a computer or an instance in the cloud. Um, Now let's look at the storage as a service. So usually you use these services to make sure that the data will not be lost and data will be there as whenever you want to access them. So that is why we usually use a database. And in this scenario, a database will be provided you as a service. So you just pay some money and say, okay, I need this database to run at this amount of data. So it's just a matter of spending some money and get it done, anything you want. So when it comes to storage, you have normally the object-based storage. What is an object in this case? It's a file. It could be a PDF file, it could be a video. So you know now in Google Drive, you can upload anything there. So it's the same idea, it's the same concept when it comes to Google Cloud or Amazon Web Services, these platforms, you have these services. The first two services are such services. And the second one, you know, if you have a NoSQL database, you can simply say, I want this particular service to run my NoSQL database. Or if you have a relational database like MySQL or PostgreSQL, Oracle, you can say, I have this database. Please to create this database and make I need to access this database whenever I want. So and in-memory database, if you have a very if you have a requirement that you need to provide high availability and very fast responses, you usually use in-memory databases. So in-memory database is like a cache that you can provide in order to help your business workflows make it very fast. And big data and analytical related databases are also there. So these services are for very huge amount of data. I mean, we are calling about these sort of databases if you are working on a IoT company or IoT business related stuff. So these sort of services are also there. So yeah, the storage option is very huge. I cannot cover everything here because it depends on your requirement. So how you want to decide this now? So the first thing is every service comes with a price and there are different prices. So you need to careful which service you are going to use. And the data volume is also very important. So if you have a very small files or very small data amount of tables, it depends on the situation. So if you have very huge data like petabytes or exabytes, so these we are talking about very huge scale data set of data. You can never ever think about when you were in the high school, right? So this is happening right now because everybody is using internet and they are making data in the internet or in any computer infrastructure. So data is very important nowadays, and now we have a special science called data science dedicated to it. So data is growing so fast around the world now. So you need to pay attention, and you should not choose something you don't have right now. So you might think about starting your own business, and you might think, okay, it will grow one day that everybody is using my business. So it will not happen in next year. It will not happen in next 5 years. So in that case, you should not make your computer infrastructure thinking that it will happen in few days or it will happen in few years. It's because you need to pay some money, so it is a waste. And when it comes to availability is about how free um, how much your system is available. I mean, like, is it, if you have a e-commerce web shop, is your shop is open 24/7 and every single day of the year? So this is the availability. If a customer comes to a web shop and if the web shop is closed or if it's down, the customer will not be happy, right? So we are talking about global level now. Everything is global scale. That means if you are sleeping, it's a daytime for me or somebody else in the United States. They want to come to your shop. You cannot just say, okay, I'm sleeping now. I don't want to ask ask face to the customers. It is not like that now. So it is the concept called availability, and it is also comes with the redundancy. Redundancy is the concept that I explained few minutes ago. You should not say, okay, my business will grow and I'm going to do like this. It is not like that. Redundancy, if you do something that it is not required right now, it is the redundant waste, which you should not do, which you are losing money. So that is that concept. And the latency, how fast you need to access your data, and how important it is to be very fast. Um, so this is also a very key component that you have to decide upon which service, which data service or which storage option that you're going to use. And the bandwidth also very important when it comes to your own data center. You are migrating everything to cloud, so you need to pay attention. If you have now, let for example, if you have a hard disk in your home and it is 5 terabytes of a hard disk, now you need to put every data as a backup storage in the cloud platform. How are you going to upload these 5 terabytes to the cloud? You have, if you usually you have 32 megabytes of data. So how long will it take? So this is like, these are very real problems when it comes to at the business level scales. It is not just one computer sitting in your home. It is very a lot of computers and a lot of data that you are talking about. So in this case, you need to think about the bandwidth, and there are a lot of other options that provide these that provided by these cloud vendors to satisfy this set of requirements. So you need to also think about such scenarios. And the last part is all about logging and monitoring. So the logging is very important because if you are going to work in a company and they have their infrastructure, everything has now set up, now everything is running. But how do you know if it is actually everything is running or not? Sometimes you might think, okay, I deployed everything. Okay, now I go home, but you don't know whether it is actually working or not. So this logging is very important, that provides a direct visualization of what is happening inside your machine or inside your infrastructure. So Stackdriver, it's a software product. If I say it is similar to, for example, I'm taking an example like a Dropbox. You know, a Dropbox is a service that you can put files there, just like Google Drive, and share everything there. So it is a product, right? Dropbox was a company and they have developed their own product. So the Stackdriver was also something like that, but recently Google has bought this company. So now this Stackdriver product, it's maintained and governed by the Google. And normally this Stackdriver is a product that they developed to provide you the logging and related stuff. So it is not just a one product. It is there are a lot of different sub tools that you can use to achieve the logging and monitoring experience more happier for you. So Stackdriver log entry, it's a one line log entry. It's usually a one line or an exception message. So with this, you can identify what is going on inside your servers, and you can even scale up or down your instance groups. So instance group is a computer groups, or if you want to create matrices and trigger serverless functions, you can do that. And you can even create a message to your phone if something goes wrong, or you can even make a phone call automated. Uh, Something called, we have a page duty. There are some services nowadays you can even make a phone call to your mobile if everything something is going on in your mesh, something is wrong with the infrastructure. So logging and monitoring, it is very important because that is how you know if everything works fine as you expect. I think this is all I have for today from my side. Does anybody have any question or any doubts on the presentation that I have done so far? I guess no. So I think it's time for me to hand over the session to Aishmanta. Uh, Let me hand it. Um, Aishmanta, are you there? Okay.
Ayushmant, is he there in the meeting?
Yeah, I can see he's sharing the screen. I can see his.
Okay.
That.
All right.
But I think he's good.
Yeah. Okay. So let me give a introduction to Ayushmant before we go ahead. So he's also a graduate of SLIIT, and I think he's also done masters at SLIIT, and he's currently a software engineer at Salberg Research in Austria, and he's also a certified professional Google Cloud Architect, as well as a open source developer and mentor for OpenMRS and Linux Foundation. So Ayushmant, over to you.
Thanks for the introduction. So I don't think that we had to say furthermore. We can continue. Uh, cool. So let's move on. It's always great to talk with my fellow people from SLIIT. I'm Aish Mantha, as I mentioned, past student from SLIIT. Not that past. I graduated in 2018. So basically, I was there as you guys before 2 years back, and finished my masters in this year. And it's the first time that I'm talking to my fellow people. Feels great. So to give a brief background about me, why I'm talking to you guys today. I'm working as software engineer in Salzburg Research in Austria. I've been here for a couple of years now, and it's been a great time here. Uh, Also, as Rajesh mentioned, I'm a professional cloud architect in Google Cloud. That's why I'm talking to you about this cloud thing today. Although I'm not working with very popular cloud vendors these days, I'm still working with a few vendors which are local to the Europe Union. With that said, let's have a look what the main objective of a cloud vendor, because there are a lot of cloud vendors in this world you don't hear in your day-to-day life, even in your professional career. So the main objective of a cloud vendor is to provide servers with networking and security aspects. Likewise, this is why you guys are here as future security professionals and network professionals. Also, there are a lot of cloud vendors in the world, as I mentioned previously, we don't hear about in our day-to-day life. We normally get to hear about Amazon Web Services, Google Cloud, Azure, IBM Cloud, because they're providing out-of-the-box solutions for enterprises which make them leaders in this industry. So apart from the basic covering, they're providing solutions for the requirements like if a company wants to run a data warehouse in the cloud, and if a company wants to run a big data analytical solution on the cloud. So they're providing a lot of options for smaller scale, larger scale, and medium scale enterprises. So they can pick whatever they need, and they can continue. This is why they are the best in the industry, and they are the leaders in the industry of cloud. So as Jude talked about the network side of the cloud and the basics and other cloud components which are related to networking, we'll take a look at the security side from here onwards. Yeah, we can't directly jump into security. We have to take some steps and go there but yeah, let's do it soon. So let's first see why organizations in the world now, it's very popular, they are trying to move into cloud. So why organizations trying to move into cloud? The most important feature I see is the in cloud computing is their on-demand availability. The self-service characteristics means that the user don't have to ask for assistance from the IT department to complete their process. Simply reach out to your provider, and they will then process your request. It's already automated. It doesn't require any human hands-on on the part of the provider, so to complete any of these procedures. And another essential cloud feature is access via broad network. So in the previous talk, to talk to you about global load balancing, which enables the global presence of your services. And also this means you can use multiple and varied type of devices, such as your laptops, mobile phones, and tablets in getting the resources you need. And multi-tenant resource pooling. This is also very important. A multi-tenant model, such as the one used in cloud computing, gives multiple users the ability to share resources, but without exposing them to security risk. In other words, privacy is retained in the cloud. So for an example, imagine that you have a building housing, hundreds of individuals are there. Arguably, they live in a one infrastructure, but they still be able to keep their privacy because they live in separate flats. The tenants of this building share the same amenities provided by the same infrastructure. And this is essentially what resource pooling is all about. In the cloud, the computing resources are the ones that are pooled, so as to serve multitude of users. And then another most important reason, unarguably, the ability to scale rapidly. We call this elasticity in the cloud, or the ability to scale up or down quickly, is necessary in cloud computing in order to keep up with the demand, of course. If an application exhibits large volume of traffic, the service will not be affected because additional servers will be automatically provisioned. So in previous discussion, you got to know about auto-scaling groups, which is simply set up group of virtual machines, scales up and down according to the traffic flowing in. The elasticity simply means that the cloud can immediately provision or release according to what's needed, and this is one of the most important features in cloud as well. Also, the cloud provides reduced cost plannings in the cloud model is very important as well. When you want to establish a data center, it's very expensive nowadays. Organizations normally don't want to take that risk and also incur that cost. You need to purchase the right equipments and hire technicians to install and manage data centers. But when you shift into cloud computing, you will only pay for the service procured. And then technical traditional computing systems require backup plans, especially for data storage. A disaster can lead to permanent data loss if no backup storage is in place. Users do not require any such means when storing data on cloud if the data is always available as long as the users have internet connections. Sorry about this. Some business cloud computing service as backup and plan for disaster recovery, like a hybrid solution for their systems. So the main system is running on the on-premises server sometimes, but still the backup is there in the cloud, and disaster recovery solution is also in the cloud. If something bad happens to your service, then they will switch into that disaster recovery plan. So last one I thought about adding here is the wide range of options which cloud can provide for a specific problem, which sometimes helps small, medium, and large scale enterprises to identify the best solutions for them. So basically, you can choose the service providers with the best features and rates for your services that your business needs. So these are the key points I see why organizations are tend to move to the cloud. So to give a brief summarization, organizations are trying to move into the cloud to protect their data, cut off unnecessary costs, to performance, because when it comes to business, it's all about providing the best for their clients. Cool. Now we know why we are moving into the cloud. It's very easy for company owners to say, yeah, let's move on to the cloud and let's resolve this mess we have by taking their services. But as security and network professionals, there are a lot of things that you have to take care about when it comes to this big step. Unfortunately, for us, for them, the higher management normally don't see this part, because there can be a lot of concerns when it comes to a big step like this. Of course, first you have to do a research, because there are boundaries in cloud. Sometimes it's possible for move, but sometimes it's not. Some applications which are there in your on-premise service, sometimes it's not possible to move. So let's have a look what can be moved into cloud first. So normally it's very easy to move new applications with less dependencies, and some applications with no or few licensing requirements, of course, because compliance plays a huge role in migrations. An application which can be scaled is a good choice as well. Also, an organization we should look at, as an organization, we should look at the ROI, the return on investment. For an example, if it's expensive to run on premises, then the best choice again is the cloud. This is the easiest bit. So what are the hard to move? Of course, applications with more dependencies are hard to move, less, and also less tolerant to scaling, and have complex licensing requirement is very hard to move to cloud as well. You know, there are a lot of bespoke applications which are written in a way that cannot be scaled. So sometimes your team have to do workarounds around it, and then start the cloud migrations. And applications require specialized or older hardwares or compliance requirements, or sometimes not cloud compliant license, like Oracle DB is a good example on which cannot be moved into the cloud. So these things actually cannot be moved into the cloud. So you have to decide what is your situation. If it's possible for us to move into the cloud, then there are best practices defined by cloud vendors on migrating your servers to the cloud. So we'll have a quick look at the steps as well. First, of course, you have to assess the service, which can be mapped to your requirements. If it's not there, what are the workarounds? These things should be assessed. And then the next step is the team should run a pilot, which will help you to understand whether it's possible to move your services or not. Yeah, sometimes it's possible, sometimes it's not. In the assess phase, you have to try and map the services that you have with the services provided by the cloud vendors. Sometimes you have to do workarounds, sometimes you have to move to new solutions which is provided by the cloud, but that's up to the management to take decisions on. If things are good, and if the pilot went well, you can give it a try, give it a go. First, you are moving the data persistence. There are a lot of options, as we discussed in previous session, to show whether it's relational data, non-relational data, whether it's files that you want to store. The first thing you should do is persisting your data and moving your data to cloud. Afterwards, we can move applications. That's the final part to do. So applications can interact with these data sources and perform their day-to-day actions. So, and later on, you can also do cloudify and optimization according to your need, according to your enterprise need. For an example, if you're a small scale business, you don't need solutions which are provided for large enterprises in cloud. So you have to think about it carefully and then uh, optimize the solution according to your need. Cool. Now we have moved our application to cloud. Then comes actually the hard part, optimization, security handling, which we have to take care separately. Security is actually not only about identity and access management. Yes, sometimes you will have your own mechanisms for applications to manage the identities. In that case, you don't have to use the services provided by the cloud. Still, to stay away from intruder attacks and any other hacks, we have specific servers provided by the cloud, and also there are best practices as well we should follow in the cloud. Also, in the cloud, a lot of people forgot about the shared responsible model, where providers are doing their work, and we have to make sure we do our part as well. So let's have a look at some of the security risks that we have identified in 2020 for the cloud. Of course, first one is the data breaches. Data is the most valuable asset for a company. It can be disastrous, and even companies go bankrupt to the extent if there's a data breach. Of course, there can be a lot of consequences of data breaches. For an example, impact to reputation and trust of customers or partners. All things that we have built up to now will be gone in a few minutes. Also, sometimes we will lose our intellectual properties, normally IPs, to our competitors. So this actually happened for me twice as well. So which may impact your product releases as well. Then regulatory implications that may result in monetary losses as well. And the other big thing is the brand impact, which may cause market value decrease, and also legal and contractual liabilities. And then, of course, directly or indirectly, financial expenses incurred due to incident response and forensics. So next is the misconfiguration and inadequate change control. This one is most common challenge of cloud in 2017, a misconfigured AWS simple storage service, S3 bucket, we say, exposed detailed and private data of 123 million American households one time. The data set belonged to Experian, a credit bureau, which sold the data to an online marketing and data analytics company called Altrix. It was Altrix that exposed the files. Such instance can be very disastrous. Then lack of cloud security architecture and strategy. Worldwide organizations, as I mentioned previously, are migrating at least portions of their IT infrastructure to public cloud these days. One of the biggest challenges during this transition is the implementation of appropriate security architecture to withstand cyber attacks. Unfortunately, this process is still mysterious for many organizations. Data are exposed to different threats when organizations assume that cloud migration is only a lift and shift of simply porting their existing IT stack and security controls to cloud environment. Also, as I mentioned previously, lack of understanding of the shared security responsibility model is also another contributing factor for such disasters. And then the insufficient identity, credential access, and key management. Cloud computing introduces multiple changes to traditional internal system management practices related to identity and access management. Of course, it isn't that these are necessarily new issues. These are always there for us, for a company, for a product development company or client-based company. It is always there. This is not a new issue. Rather, there are more significant issues when dealing with the cloud, because cloud computing profoundly impacts identity, credentials, and access management. In both public and private cloud settings, CSPs and cloud consumers are required to manage them without compromising security. The next one is the account hijacking. Account hijacking is a threat in malicious attackers gain access and abuse accounts that are highly privileged. In cloud environments, the accounts with the highest risk are the cloud service accounts or subscriptions. So cloud service accounts are there when you want your services to interact with each others. This is normally even in cloud IS services, internet IT services, as well as if you're using open source IT services. The service account concept is always there. So this is why we should provide the least privilege access to these kind of accounts. And normally in cloud, we say if someone requires access to your cloud to do some work, give the least privilege to him to do his work. So likewise for these cloud service accounts as well, you have to provide least privilege in order to perform only their work. Phishing attacks and exploitation of cloud-based systems or stolen credentials can compromise these accounts. Then the insider threats. So this is about employees, the future you. In the Nutrix 2018 Cloud Security Report indicates that 58% of companies attribute security breaches to insiders. Inside negligence is the cause of most security incidents. Employees or contractors' negligence was the root cause of 64% of the reported inside incidents, whereas 23% were related to criminal insiders and 13% to credential theft. So this is why in day-to-day life, when you go to the industry, normally when you're even going to the washroom, they say to lock your machine and go, because you don't know about the environment that you are staying at. Sometimes these kind of credential theft or things can happen. So this is why it's always mentioned by the seniors. Whenever you go out from your cabin, make sure to lock your machines and go. So this is very important because we have, as employees also, we have these kind of responsibilities because we are working with our clients' data. So it's very important for us to keep these things in our mind. Some common scenarios like misconfigured cloud servers, employees storing sensitive company data on their own insecure personal devices and systems, and employees or the insiders falling prey to phishing emails that led to malicious attacks on company assets. It can be anything from the mentions above which can cause these kind of troubles. Then comes the insecure interfaces and APIs. Cloud computing provides a lot of software user interfaces and APIs, which allows customers to manage and interact with cloud services. The security and availability of general cloud services are dependent on the security of these APIs. From authentication and access control to encryption and activity monitoring, these interfaces must be designed to protect the APIs, of course. So in the near future, if you are working as a security professional and you have a development team working with you, make sure at least they have access control tokens in place for the services that they are developing. Of course, as Jude mentioned, microservices are very popular these days. A lot of companies here are going to these architectures because it's very easy for developers because they are only focusing on some work, only some work, specific work a microservice can do. So poorly designed APIs could lead to misuse or even worse, a data breach, because as we know, APIs are interacting with databases. So if someone misuses the tokens that we are passing, and if someone misuses of APIs, if we haven't secured them, there can be data breaches, and broken, exposed, or hacked APIs have caused some major data breaches in the history. Organizations must understand the security requirements around designing and presenting these interfaces on the internet is very crucial. This is a very crucial thing, of course. Make sure to secure the endpoints whenever that you are working in an ecosystem like this. The final thing I would like to talk about is the weak control plane. Moving from the data center to cloud, it poses some challenges for creating sufficient data storage and protection program. The developers must now develop new processes for data duplications, migrations, and storage. If using multi-cloud, this even get complicated, very complicated. A control plane should be a solution for these kind of problems, as it enables the security and integrity that would complement data plane that provide stability and runtime of data. But if a weak control plane is there, means the person in charge, either system architect or your DevOps engineer, is not in full control of the data infrastructures, logic, security, and verification. This scenario, controlling stakeholders don't know the security configurations, how data flows, and where architecture blind spots and weak points exist. These limitations could result in data corruption, unavailability, or leakage of data. So these are the things, these are the cloud security challenges that we are facing in the 2020 when we are moving our applications. And also, I would like to share a few of my experiences from my end. So for login and to monitoring dashboards in here in my company, we're using Elasticsearch. I'm not sure whether you're familiar with it. It's a central place where you can view all your microservice login events, and let's say like that for now. One time, one of our developers mistakenly have logged the access tokens inside the controller and have pushed the logged into ELK stack. And it was not our concern to secure the ELK endpoints, but later on, some attacker have got that token, and he tried to access our data endpoints of a microservice called business process service. So as I mentioned previously, we are in microservice architecture. So there are a few services, a lot of services that we're developing. So these services are taking care of only their part. So when it comes to business process service, it's very important for us because it contains a lot of important information regarding our clients. And fortunately, the token had the least privileges. And when he was trying with multiple bots and multiple time, we discovered the issue lately. Then we secure the LK Kibana dashboards to not expose logs to anonymous users. And also, there are a lot of bots trying to SSH or VMs normally in the world. I hope because there are some security professionals here. You might know, because I have seen in a day there are at least 100 at least 1,500 IPs are blacklisting in the VMs that we are using here. So make sure to have at least a blacklisting mechanism enabled in order to blacklist IPs after few failure attempts. And another funny incident happened to us when one of our very, very popular partner, I can't say the name that we work with in our project, used a very weak password for a database one time, which can be guessed by hackers or bots. He was complaining all the time the services were not working. So I SSH into machine and connected to the DB through a local tunnel. There was a message by a hacker saying your DB password was too weak. I hacked it and I stole all the data you had. If you want it back, send me a Bitcoin, something like that. Fortunately, it was just a test deployment that we had. Likewise, in every organization, these things can happen. So make sure to take care of these things when you're working in the industry. Nice. So let's have a look at some of the services and features provided by cloud for us to overcome these situations. In Google Cloud, if you take Google Cloud, they provide multi-layered security, which is promised by them, their side in this shared responsibility model. So operational and device security, they develop and deploy infrastructure software using rigorous security practices. Their operation teams detect and respond to threats to the infrastructure, them both insiders and external actors, 24/7 all over the year. And next one is the internet communication. Communications over the internet to cloud services are always encrypted in transit, and the cloud providers promises network and infrastructure have multiple layers of protection to defend their customers against denial of service attacks. Next one is the identity. identities, users, and services are strongly authenticated with multiple factors. Access to sensitive data is protected by advanced tools like phishing-resistant security keys. And then the storage service data stored on in cloud infrastructure is automatically encrypted at rest and distributed for availability and reliability. This helps guard against unauthorized access and service interruptions. Service deployments, any application that run on Google Cloud infrastructure is deployed with security in mind. So the cloud providers don't assume any trust between services. They have multiple mechanisms, of course, like service accounts and things to establish and maintain the trust. And the hardware infrastructure, from the physical premises to the purpose-built servers, networking equipments, and custom security chips to the low-level software stack running on every machine. The entire hardware infrastructure in Google controlled, secured, built, and hardened. So this is the multi-layered security, which covers almost very vital areas in their cloud, and they are promising these things in their shared responsibility model. This is why we should move to cloud vendors like this, because they provide these kind of solutions for us, this kind of compliance compliances and this kind of security for us. Also, like this Google Cloud as well as Amazon Web Services, they are providing this kind of security for their clients. Okay, let's have a look some of the services, actual services which are going to make it easy for us to do our security from our end. First, it's access transparency and access approval. Yes, this is about logging activities that you talked previously. It plays a vital role in security, of course. Explicitly, it'll approve access to your data or configuration on Google Cloud, and access approval requests, when combined with access transparency logs, can be used to audit an end-to-end chain from support tickets to access requests to approval to eventual access. Then access justification, view the reason for each access, including reference to a specific support ticket where relevant as well. Then the resource and method identification. So when someone accesses the resource, access for one time, what are the exact resources that administrators have access, and methods they have run on. This will give an insight like that. And cloud login integration. Integrate seamlessly into your existing cloud login configurations, and you can easily create alerts which will fire alarm emails or SMS or Slack notifications based on these rules. For example, if an intruder enters platform and provisions multiple virtual machines for Bitcoin mining, let's take that for an example, and it's very common these days. So what we can do is we can create quotas in the Google Cloud, which limits number of resources that an organization can create. And if it goes beyond the limit, we can fire emails with the support of Cloud Login, which will notify the parties which are taking care of this cloud environment. Then you can also view the location of the accessor, with the country in which administrators are performing the action was based on. So you can have a look at where are they from. If they are not from a place that you know, where don't know, then you have to take care of it. And don't worry, there is always an audit trail, means a log when they log into your cloud platform for sure. Then comes cloud data loss prevention, which is a fully managed service designed to help your discovery, classify, and protect your most sensitive data, like credit card details and these kind of things, your secrets that you have inside your data. So key features like data discovery and classification with over 120 built-in info types. Cloud DLP, data discovery and classification, gives you the power to scan, discover, classify, and report on data from virtually anywhere. Cloud DLP has native support for scanning and classifying sensitive data in cloud storage, BigQuery and data store and streaming content API to enable support for additional data sources, custom workloads, and applications. These are the places that these kind of data sets can enter to this cloud platform. That's why they have given this kind of support for these services. It will automatically mask your data safely and unlock more of the cloud as well. Cloud DLP provides tool to classify, mask, tokenize, and transform sensitive elements to help you better manage the data that you collect, store, use for business or analytics. Of course, when it comes to the analytical part, you can't expose these kind of data. This is why these kind of services are very important for us. You can't expose the credit card details during an analytical solution. So these kind of APIs, these kind of services are there in order to prevent that kind of scenarios. Next is the cloud key management, encryption keys on which manage encryption keys on Google Cloud. It centrally manages encryption keys. It's a cloud-hosted key management service that let you manage symmetric and asymmetric cryptographic keys for your cloud services. The same way you do on-premises, you can generate, use, rotate, and destroy, because this is the best practice. We can't keep it forever. You have to time rotate this cycle, of course, these cryptographic keys. Also, delivery hardware key security with HSM and hardware security module, and also provides support for external keys with EK, which means encrypting data in BigQuery or Compute Engine with encryption keys that are stored and managed in third-party key management systems that deployed outside Google's infrastructure. Normally, these external keys are a good choice if you are not running your solution. Is a good choice when you're not running a solution inside Google Cloud or any other, if it's AWS, not inside AWS cloud. So if you are using Google Clouds or that specific cloud vendors services in order to deploy your services, you should take a look at the internal key management solutions, internal keys that they are managing, because it's always it's very accurate, and it's more easy to use as well, and maintainability is high. So of course, they say if you are using your own infrastructure, then go with your own keys. So we have provided this kind of cloud key management solution for you. But if you're using our environment, make sure you use our key management service. That is the best practice. Okay, move on. Next is the Google Cloud Firewall. In all the clouds, there are firewalls like this. It's a fully embedded in the cloud networking fabric, highly scalable and granular to meet the enterprise's unique security needs, of course. It's flexible and customizable, benefits from protection at the organizations. Normally, in Google Cloud, there are organizations, folders, and projects. Then comes the resources, virtual machines, virtual private clouds. So at any level, you can define your firewall policy. It's customizable up to that level. So this is the least thing that we can do from our end, having a firewall and securing our instances from outside threats. So the next thing is the secret manager. So this will help you to build more secure applications with the secret manager. Secret manager is a secure and convenient storage system for API keys, passwords, certificates, and other sensitive data. Secret manager provides a central place and a single source of truth to manage access and audit secrets across Google Cloud. And also with this, least privilege made easy. It's easy to follow that. Easy to follow with the principle of least privilege with secret manager, manages cloud IAM roles. You can't grant individual permissions, secrets, and separate the ability to manage secret from the ability to access their data as well. Next one is the cloud identity. It's a unified identity access up and endpoint management platform that helps IT and security teams maximize users' efficiency, protect company data, and transition into a digital workspace. So one of the main things I want to point out here is the hybrid identity management. Of course, account security is there, device security is there, and there's a management console where you can take care of things, and automated user provisioning is done with this cloud identity. And the the most important part is hybrid identity management. Whereas there are a lot of companies still using, if you heard about Microsoft Active Directory, LDAP, where they store their own users inside that LDAP. So if you have LDAP like that, if you want to sync that, if you still want to use that LDAP users to authenticate and authorize into your cloud, you can do that with this cloud identity. They provide that services which you need in order to perform that actions. Cool. Next is the cloud identity and access management. This is different from the previous one. This is a fine-grained access control and visibility for centrally managing cloud resources. This gives you the ability to single access control interface, which provides you single access control interface, fine-grained control, automated access control laws, control recommendations. It will automatically say you this is an unwanted access to GCP resource with smart access control recommendation. These are like new solutions that they were coming up with in the Google Cloud using recommender. You can automatically detect what are the unwanted access that we have given to specific users or accounts. So you can easily remove them without going furthermore and making your cloud at risk. Also, it gives you flexible roles. Previously, in all cloud platforms, we had basic user roles. Later on, they came up and said, okay, we are providing these kind of roles for you, so you can use it for granular level services that we are providing at the granular level. And this is very important because this will help you to separate out the users that you have and provide the users that the access they need in order to perform their operations. Of course, if you are using Google Cloud platform, this Cloud IAM is free for Google Cloud customers. You will be charged only for use for the Google Cloud services. For the Google Cloud services, it's very important to have this Cloud IAM. So also, it has a built-in audit trail to ease compliances process for your organization. A full audit trail is made available to admins without any additional effort or additional cost. So these kind of options are provided to you by Cloud ID and Access Management. Then we have a few APIs for phishing protection, which will protect your user from phishing sites. The majority of cyber attacks begin with phishing emails and websites. Attackers use many tricks, including by leveraging enterprise brand assets such as company names and logos to develop phishing websites that appear authentic and your internet users to enter valuable information such as usernames and password. So this phishing protection helps prevent users from accessing phishing sites by identifying various signals associated with malicious content, including the use of your brand assets, classifying malicious content that uses your brand, and reporting the unsafe URLs to Google Safe Browsing. It has a flexible API, detailed phishing URL reports, and you can view detailed reports that provide an overview of the unsafe pages that have been found and added to a safe browsing list in Google Cloud. And also it has safe browsing integration as well. Report known phishing URLs to safe browsing so that users are warned before they click infected links. It'll help you to identify these infected links and prevent you from clicking them. Next is the web risk. It detects malicious URLs on your website and in client applications. Web risk is a Google Cloud service that Client applications checks URLs against Google's constantly updated list of unsafe web resources. Unsafe web resources, including social engineering sites such as phishing and deceptive sites, and sites that host malwares or unwanted software. With the web risk, you can quickly identify known bad sites, warn users before they click infected links, and prevent users from posting links to known infected pages from your sites. Web risk also includes data on more than a million unsafe URLs and stay up to date by examining billions of URLs each day. There are a comprehensive list of known unsafe URLs also in the list, so you don't have to worry a lot about these kind of things now. And in the future, it will be more developed more, so it will help you more in these kind of to prevent from this kind of risk. And there are very good support from Google Cloud to integrate these things to your application that they provide. Lookup APIs, update APIs, which will help you to automatically update things and get the use of services like this. So we talked about around 10 services which are provided by Google Cloud in order to handle your security. So I think for today, that's it. The time has already passed. So thank you. I hope you enjoyed my presentation, and it's great to talk with you again. If you have any questions, please let me know. And also, if you, as university students, you want to participate in open source competitions like Google Summer of Code or Outreach, please come to us, to me, or either Jude. We'll be able to help you to get started as well as get going, sometimes to get a position as well. So that's it from my end, and thanks a lot.
Okay, so thank you very much, Jude and Ayushmanta, for the valuable presentations and your time. So I think if you have any questions, you can ask the questions either through chat or you can ask the question here. Any questions? Okay. So I think if you have any questions, you can contact Jude and Ayushmanta. So thank you very much for the time, guys. Have a nice day.